profiles. And then the third one that we just did was how to build subassemblies. So those are the three, and right now you can see on my screen, I hope, you should be able to see my surface over here with the contour lines. You should be able to see this black line here, which is our created alignment. And then over here on the right, you should be able to see the profile of that created alignment and the design grade. It's a little hard to see. I can zoom in later, but just want to go over all these parts. And then down here, this little section down here, if I zoom in, these are my created two assemblies. Last time I showed you how to build one, but how you build one is how you build all the rest of them. Okay, but these are the two we're going to be using today. And those are the steps we've gotten to this point. Then we're going to teach you how to build a corridor today. So the idea of a corridor is taking these little cross-section sub-assemblies, and think of it like you're grouting cinder blocks. You're basically going to take your spoon and push it through the ground and create this shape in the ground, and it's going to be based on the profile that you created in the previous step. Okay, so it'll go at this grade, at that shape. And that's what we're going to do with corridors today. So I'll go ahead and jump into it. As Justin said, if you have any questions, go ahead and type them in a line, and he can interrupt me at any time and ask them if they're pertinent to the situation. Keep us kind of informal like all the rest of them. So let's just jump into it. The first step, and you should have a set of notes here. If you don't have them, look on the GoToWebinar screen. There should be a PDF there where you can download it. But just like all the rest of them, we're going to follow step by step. And step one is called creating a corridor with one assembly. Okay? So the first thing I want to do is go up to the ribbon on the Home tab, and I want to select Corridor, which is this button right here in the ribbon. Okay? So I'm going to click that. And I want to name my waterway. For instance, if I have one waterway, and this first one we're going to do the same size all the way to the end of it. I'll just call this the north waterway. Maybe there's a south one or an east one, or this is waterway 1. Whatever you call this waterway, we're just going to change it to that name. I'm going to choose the alignment that we created in the previous steps, which is what I call the WW alignment. This could be waterway 1 alignment. This could be north waterway alignment, whatever you called it. Just make sure you choose the right one. Okay. Then I have to choose the right profile. And if I open up this drop-down list here, you see that I have 4 different profiles created. This first one is the -20, and this one below is the -20. The third one is the points EG surface, and the fourth one is a waterway design grade. These first 3 are profiles of the existing ground surface, which is not what we're going to use to cut in the waterway. We have to use the design grade. So in other words, if I go to the profile, I want to use the blue line that I created here. That's my design grade. Okay, so that's the one I'll pick, and then I have to choose the assembly I created in the previous step that's going to represent my waterway size. And for this one, I'll just choose 40 foot wide, 1.2 foot deep assembly. And then the last step in this box is to choose the target surface. Now the target surface is basically the existing ground that you created, that once this thing cuts into the ground, it's going to have to find that existing ground somewhere so it can tie into. And so if I have multiple surfaces, I just want to make sure I pick the one that is the appropriate one for the current existing ground. Okay? And then I'll just click OK. All right, then I get this other dialog box up here, which is the baseline and region parameters box. This is then, if you're following along the steps, this is part C of that first one. No, I'm sorry. This goes into step 2. So this box pops up in the previous dialog box. At the very bottom, there's a check mark box that if I uncheck this wouldn't have popped up. But I always want this to pop up because I want it to remind me that if I have any other waterway sizes that I want to add to this grass waterway, I can do it right here, okay? But since I'm only doing one grass waterway size, I don't have to do anything here. Now, I'll go into more detail of this stuff in the next step, so I'll talk about that here in a little bit, but I just want to show you how easy it is to create a single corridor. So I'm going to click OK. And I'll get this dialog that pops up that's asking me if I want to rebuild the corridor. And you could check mark this box in the lower left-hand corner, and then you could hit the rebuild corridor, and then this box wouldn't pop up any other time. It would just automatically rebuild the corridor. But I'm going to go ahead and click it and leave that on so that it always notifies me when it's building a corridor. And anytime you do this, you will get this action box pop up like I did, and you can see all these errors on the left, and it is important to understand what these errors are, but as far as what it takes to complete the job, we won't look at this until the end. Okay, so this is kind of telling us some of the issues the corridor had. It's not saying that the whole thing's bad, it's just saying watch out for some of this stuff. Okay, it could really affect some of the values. But for now, there's this green check mark in the top right-hand corner. We're going to click that. Okay. So if you look on my surface down here, you'll see I now have these purplish lines. Okay. This is the corridor network. If I zoom in here a little bit closer to it, you can see the center black line is still my same alignment. Okay, that's the center of my proposed grass waterway. And then these purple lines are where the grade breaks would be within the grass waterway cross section. So this first one on both sides would be the 10 feet out, and it'd be, I think, a quarter of the depth. Okay, so if you remember how we built the sub-assemblies, we had these different cross-section links all connected together. And then these two outside purple lines right here, those would basically represent the top of my designed waterway. In this case, it was 40 foot wide. So between this purple line on this side to the outside purple line on the other side, that is 40 feet apart. Okay, but then because the profile wasn't properly designed at the right spot, and I did that on purpose, it has to find the existing ground somewhere. So from the edge of the grass waterway, it's going to go out and find existing ground, whether it's above or below this this point on the grass waterway. It'll go out some distance based on how I built the assembly to find that. So this outside red line here on both sides, that is where you would cut the slope to meet the existing ground if you were below grade, and it was where you would fill to meet the existing ground if you were above grade. And you can see it's at different distances on both sides of the grass waterway. This one is out here on this top side, and this red line down here is a little bit further out. All that's telling me is that on this side it's got to go a little bit further to find the existing ground to tie into, okay? But that's what the corridor looks like on screen. You can see that it basically has this representation all the way down the surface. Okay, it'll go all the way to the end. Okay, but this really doesn't tell me a whole lot if the waterway is good or not. I kind of know from experience that, well, the red line means that I have to fill, so that I basically have to fill everywhere on the outsides, which is not a good waterway design. Okay, but there's something we can do that's a little bit easier to sort of fine-tune the plan and design. Okay, so if you're following the notes, I'm going to skip around a little bit in the notes because this is kind of important. If I jump around to step 3 on the notes, which is the section editor, I'm going to go ahead and open that up. So to do that, I select the corridor, and I go up to the ribbon, and there's a button here that says section editor. I'm going to go ahead and select that. and my screen just changed. It just split in half. On the top half I have the same model space view that I was in, and on the bottom half I have this thing that sort of looks like a cross section. Well, it is a cross section, okay? It's a dynamic cross section that changes anytime I change the corridor, and it will also help me decide how deep or how shallow my waterway is compared to the existing ground. So the way this works is I can choose whatever station up here in the top ribbon. I can click the drop down right where it says select a station, and I can pick any station I want to see. Let's say I want to check out the station at 300, and I just want to see what the cross section looks like there at 300. At the bottom you've seen I just changed to where I'm at, and this is going to be kind of hard for you to see on your screen. But let me zoom in here. This bottom red line, this right here, this is what is representing my existing ground. And if I hover over it, I'll get this little pop-up box that'll say, in there it'll say points EG. That is telling me that that is the contour lines of my my existing ground surface. Okay. Then the top line, this purple line, is the corridor. It's what would look like if the contractor built what was designed as it is. Okay. So if I hover over that, you can see this pop-up box tells me that it's a sub-assembly link for the North Waterway, and it's the corridor. Okay. So I know that that's the cross section that I'm trying to build, but I can use this tool to be able to tell me that, hey, this area right here, I would build it above existing ground, and I'd have to fill all of this in to meet the existing ground, which is not good design case because no water can flow into the grass waterway from this point. So if I zoom out, I can see my center line is here where this red dotted line is. If I zoom in a little bit on that, I can see that the bottom of the grass waterway is just slightly below the existing ground, which usually that's not how it happens. Usually we have to cut quite a bit in the center line. If you're familiar with grass waterways, you usually have to cut the most in the center. Okay, so that there tells me that it's also not a very good plan. So let's go ahead and look over to the left side, and you can see that on this left side, it's the same situation. I'm coming to the end of the edge of my grass waterway is still above the existing ground. Okay, so I know that's not good. But this is a good planning tool because this allows us to adjust everything dynamically. So let's say, okay, I know that's not good. I have to go to my profile and I have to change the profile grades. So what I can do is I can click in the model space up here, scroll down, and I go to my profile view. I don't know if you guys can see this yet or not, but if I zoom into my profile view, okay, I'll go somewhere here towards the middle. And this was a bad design. Clearly, you guys knew this. You knew this ahead of time because my design grade is at the same level as my two low banks. So, okay, if I had a waterway that's 1 foot too deep, I know that I'm going to have to fill because I'm at the same level as my two low banks right now. So to change that, I'll just click my design grade line, and I'm going to click this middle triangle, and I'm going to drag it down to about where I think it should be. Okay, and I'll click. Now let me zoom out a little bit. Let me get out of section editor real quick so you can kind of see this full screen if I can figure out how to do it. Okay. Okay. Just bear with me just 1 second. I know this is kind of lagging on your screen. Okay. Hopefully right now you can see the profile view as it sits right now. I just dropped the middle point down, say, 1 foot or 2 to where I think is going to be a better representation of where the grass waterway should be. Now that did change my slope, so that might change my grass waterway size. You're going to have to run through the EFT program a couple times to get it right. But I can still adjust this stuff on the fly. So let's go back to my section editor and see if that changed anything. Well, if I look at the corridor, it doesn't look a whole lot different than from when the first time I showed you. Well, that's because in the first step where I said click to rebuild the corridor, we didn't check mark rebuild automatically. So what you can do is you go over to the Prospector tab and find the section where it says corridors and open that up. And you'll see where it says North Waterway, it's got this yellow sign that's basically saying, hey, something changed, but I haven't updated yet. So all you have to do is you have to right-click that and go down. You can select Rebuild Automatic. So that means anytime I adjust something from this point on, it'll automatically rebuild that corridor without me having to go through this step. Now, whether or not to do this is up to you. It depends on how powerful your computer is. If it's very good processing speed, then you don't necessarily have to do it individually every time. You can do this automatic one. But if you have a slower computer, an older computer, this might bog down your processor, and you may have issues. So it just depends on your computer equipment. But I'm going to go ahead and click this, and you'll see it'll go through the same whole process when I did the first rebuild. I'll just get out of this error box with a green check mark. And now you can see the corridor change its boundaries just a little bit. Okay, we no longer go way out here to find the existing ground, okay? But I still want to check it with my section editor. So again, I'll select the corridor. I'll go up to the ribbon where it says section editor. And I'll go to station 300 because that's the one I want to check. And you can see, I hope, that this bottom section editor screen here, the waterway fits much better in the existing ground. Okay, so I'm still cutting pretty deep here in the center. And if I go on the left side, the edge of my waterway ends right here at this red point, and then it's cutting another 6-to-1 slope to find existing ground. So it's maybe a 2 or 3 or 4 foot cut to find existing ground, which is pretty good. Okay, so let's just check the right side. And you can see on the right side, I'm still going above the existing ground to fill. And maybe that's not a huge deal. Maybe this can find ground that slopes upward to where it can tie in. That's okay. But what you want to do is you want to go through all of your stations. So every 100 feet, or go wherever the waterway changes sizes, or go to the turns. Things that are important, you want to check those stations. So I just go up here to the ribbon and I change to different stations, or I can hit these 2 arrows on the right, can take me to different stations, okay? But I'm just going to go ahead and quickly look for station, let's say 750. I'm just guessing. Okay, something went terribly wrong, and I feel like it's going to crash, and I hope it doesn't, but let's see here. It's drawing this line. I don't know what it's drawing. Let's change the station and see if that doesn't help. Okay. I think I can explain what happened. The corridor, you've seen that the action box popped up when we rebuilt the corridor. It's saying I had an error at one of the stations, and I'll explain it in a little bit, but basically the corridor is trying to build on top of itself. And certain areas are going to have those issues. And there are ways to get around it, and there are ways to kind of ignore it as well. But we'll talk about that at the end of this presentation. But anyhow, I'll go to station 800 for now to show you that if I keep checking my station like this, you can see the purple line. It's everything's below grade, and when it gets to the edge of the waterway, it cuts 6-to-1 slopes on both sides. So that fits pretty good. Okay, that's the type of design process you would use for this. You would keep going back and forth between your section view and your profile view to fine-tune your grass waterway at each station, okay? And if you do stations, say if you do cross-sections at every 300 foot typically, then basically go every 300 feet stations and check it to make sure it looks good, okay? So just kind of keep going back and forth. And you might have to go back to EFT. You might have to use the waterway sizing wizard to readjust your grass waterway size because your grade changes. So it's kind of a sort of a multi-step thing to where you have to kind of go in full circle to get this to your final design, okay? But that's how you build a corridor. Not too terribly difficult. You just have to use it from then on to kind of manipulate to where your grass waterway goes and how it's sized and what the final grade is, okay? The thing I wanted to show you, though, is that I only showed you how to do one grass waterway size. I'm going to show you now how to do more than one grass waterway size in the same waterway. So say the grade changes significantly to where you have to go to a 50-foot wide grass waterway 2 foot deep, or if it's flat up top and you only need to go, say the standard alternative design is 32-foot wide 1 foot deep, okay? That's the one I'll show here today. So I'm going to go ahead and get out a section editor, and I'm going to delete my corridor because I'm going to build another one. And I still have my my original alignment here on page. Okay, so I'm going to go through the same steps. I'm going to go up to the Home tab. I'm going to go to Corridor. I'm going to make sure it's the right corridor name. I'm going to select the right alignment. Select the right profile. Remember, this has to be our design grade. Select the right assembly. And in this case, when you're doing multiple assemblies on a single grass waterway, you want to start with the one that is closest to the outlet. So, for instance, if the bottom of your waterway starts out 40 foot wide, 1.2 foot deep, and then as it goes upstream, it gets a little smaller, you always start out with the one downstream. You start out with the biggest one, or in the case, the one closest to the outlet. Okay, so I'm going to select that one, and I'm going to choose my target surface again, as always, my existing ground surface. Okay, and this is where I talked about before, this check mark here. If I uncheck this, I wouldn't get the pop-up screen where I can adjust some of the stuff. So I always make sure that's a check mark, even when I'm only doing one, just so it sort of reminds me that I can adjust it after this point. Okay, this is the one that pops up. Now there's some things here I should probably explain what they mean. Particularly this one over here, the start station, is where this this assembly will start to be put into the grass waterway, and the end station is where it'll stop. Okay, the frequency is how often it tells the corridor to build that cross section from the assembly. So in this case, it'll build it at the starting station, and then it'll build it at station 25, 50, 75, 100, and then between those two areas that it built, it'll connect the lines. So it's a smooth line looking corridor, okay? And for now, I'll set it to a 25. 25 is fine. If you set it any smaller than this, it might take some time to process. Again, if you have a slower computer, it might take a lot of time to process. But for now, we'll leave it at 25, but just know you can adjust that if you have some issues in the corridor later. The target surface, I already set, was my existing ground, but for other purposes, there are reasons you may want to use different surfaces, so you can select individually here. Okay, those are the main things you need to know. The step to add a new size is, if you're looking, this would be step 2. So I jumped to step 3, now I'm back to step 2. But if you're looking, this would be step, let me find my point here. This would be step E, okay? I want to go up here and I want to left click right here in this area, and I want to select add region. Basically, I'm adding a new region of stations that is going to tell me the area where we're going to put in this specific grass waterway size. So I'll add the region, and since I'm going to use the 32 foot wide, 1 foot deep section, I'm going to go ahead and name that 32 wide, 1 foot deep, and click OK. You can name this whatever, but this just helps me keep it straight so I know which stations go to which cross sections. Okay, and you can see it just added a new cross section area down here, but it hasn't yet built it yet because we haven't assigned a station for it to go to. So to do that, you first have to change the first one. Let's say this first one I want to end at station 400, and from 400 to the end of the waterway, 1265, we're going to use the 32-foot wide one. So we'll just say 400, and I'll hit enter. And then I have to select the start station for the 32-foot wide waterway, and I'll make that 400 because where I end the first one, I'll start the second one. And I just make sure that the end station is 1265. Now, if you have more than two, just do the same process. Go up here and right-click and select Add Region, and then change the starting station. Select your assembly and change the starting stations. Keep going in that order until you have all the assemblies you need. Okay. Now, the next step is I have to set the target surfaces. Okay. The main way that I do that is I go up here to where it has a target column, and I select this top 3-dot button. Okay. I could do this, or I can go up here and I could select Set All Targets. Okay. They'll both do the same thing, but I have to do this step because I have to tell it that it needs to assign the 32-foot wide waterway to the target surface, which is our points EG surface. So to that, I'll just right here where it says click here to set all. I'll click there, just like it tells me to do, and I'll select my points EG, and I'll click OK. And then I'll click OK again. Okay. Now, I'm done here, but just know that this is a screen you may have to keep coming back to fine-tune your corridor if you have certain issues. Okay. So to get to this, all you have to do is go to your corridor properties. Okay. I'll show you how to do this once it's done, but I'm going to click OK. Okay, it pops up and tells me, I guess it's asking me if I want to rebuild it or not, and I'll say rebuild. And again, I'll get the action dialog box pops up as always. Hit the green check mark. Now, I've got this new corridor, but what I'd like to do is zoom in to see at station 400, is it changing sizes? Okay, so on this corridor you can see these purple lines. Again, these purple lines are what is represented by the size and the depth of my grass waterway. Okay, if you follow these down to station 400, and as they go past station 400 they start to curve inward. Okay, that's because you're going from, again, a 40-foot wide top width down to a 32-foot top width. Okay, so that would make sense why they get a little narrow right there. So from this point on, everything upstream of here is going to be the 32-foot wide waterway. Okay, so you always want to check to make sure that that works out in these transition areas or where you want them to be. Now, the percent grade at which this transitions is based on the frequency that you set. So what this is saying is that at station 400 I'm building a 40-foot wide waterway, and then since I set my frequency to 25 feet, I won't have a 32-foot wide waterway until 25 feet from station 400. So that's why you have this kind of easy grade down to the 32-foot wide waterway. If I would have set my frequency to say 1 foot, this thing would have changed right here, right next to 400. 401, it would have been 32-foot wide, which is not how things are built in the field. We all know that. Okay. That is the simpler, not simpler, but I guess that is a simple process for adding multiple assemblies to the same grass waterway. Now, the one thing I'm not going to show here today is how to add branches onto the grass waterway. We just don't have enough time in this one. I'll have to do a separate one sometime down the line from now. But there is a way you can add branches from here. I just haven't dove into it enough to be able to explain it at this point. So just know that we will get to that sometime in the future. Okay, so now we're going to jump. Okay, we did the section editor, And we're going to say the design's good. Now, I know some of you that do grass waterways, you may be arguing with where my profile line is for now, but let's just say, for argument's sake, that it's good. If you jump down to step 4, and you go just above there on the notes, there's a note that says the section editor is only a viewable section of the corridor. Okay, so when I pulled that up, and I'll do that here so that I can kind of explain as I'm talking about it. It pulls up this cross-section view. Let's go to station 250. Okay, this is a cross-section view on the bottom side. Okay, but it's not the cross-sections that I'm going to be putting on the plans. Okay, this is more of a dynamic view that allows us to sort of manipulate things to get the final design. Again, it's not the final cross-section view to the finished plans. It just it allows us to fine-tune the waterway data, okay, without having to redo the cross-section. So if I were to create cross-sections right now, sometimes things don't always work dynamically, and they're easy to judge. You may have to change things here and there, so this just lets us do that before we do our final set of cross-sections. But we'll do those in the next webinar. So step 4. Step 4 is creating a surface from the corridor. Fairly simple. I say that, but sometimes I still run into issues. So I'm going to get out of the section editor, and you should see my corridor here on screen. I'm going to select the corridor, and up here in the ribbon you should see corridor surfaces. I'm going to click that, and this corridor surfaces dialog box pops up, and this far left button here, if I hover over it, it'll say create a corridor surface. I hope you can see that. I'm going to click that, and you'll see that it created a corridor surface here that's the name of my waterway, and I can change the surface style if I want. Let's go ahead and change that to 1 and 5 design. And then I have to add some data to this surface, okay? The steps are, make sure your data type is set to links, and you can ask me what the difference is between links and feature type. I don't know. I just know that this is how I do it, and it works. If someone else has an explanation or maybe a different suggestion, they can certainly chime up, but for now we're just going to say leave this to links and then specify code as top, okay? And we're going to hit this plus sign here on the right that says add surface item. Okay, so you can see it just added this this top right below here. The second part to it is I have to go to the boundaries tab up here, and I have to hover down to my north waterway surface, and I have to right click and select the add automatically, and this box pops up to the right, and I want to select dialog, or not dialog, select daylight. Okay, and again, there may be other ways to do this. This is what I do. Certainly if you have other ways, chime in. We can talk about this once I finish this here. But so let's click OK. Again, it's going to ask me to rebuild the corridor. I'll let it do that. This box pops up. I'll hit the green check mark, and it's kind of hard to see because there's a lot of lines on screen, I know, but if you look hard, you can see the outline of a surface that was just created that follows the corridor, okay? And if I select it here, you can see that these created some pointed lines that are an accurate representation of what I want the grass waterway to look like once it's built. If I were to go out and survey it after it's built, this is what I want to see on my CAD screen. Okay, so to look at this a little bit easier, I'm going to go to the Home tab, and I'm just going to turn off some layers that are the corridor layers. Just for your references, the corridor layers, if they're defaulted, are C Road Core. If I go down here, if you can see this, there's 3 of them here: C Road Core, C Road Core Boundary, C Road Core Pattern. Turn all them off. Okay, and I'll type in REA. Remember, we type in REA to regen the screen. The corridor is turned off, and I can see this surface on top of this other surface here that was just created. Okay, that's this one here. So that's it. We created a corridor surface. We could go ahead and do some cross sections off of this surface and compare them to the existing ground, but I don't know why. I always like to merge the two surfaces together so that I have what I consider a finished grade surface that is a combination of the existing ground and the corridor surface built together. So it would basically, if you did the same survey you did at the very beginning, this would be what it would look like once you have them merged, okay? And this is a step-by-step process that I don't think is in your notes. I thought we did it on the surfaces one, but then I realized we took LiDAR out, so we didn't do it. But just real quickly, I have to copy the existing ground surface, and I can't just select it and copy to the clipboard. I have to go up to the ribbon and select copy. Okay, so using the copy command, I'm going to select the existing ground. Remember, this is important. Select the existing ground. Then I have to find a point of known reference that I can go back to. Let's see here. My snap is, I got to turn my snap on here so it's a little easier to do. Okay. Okay, so I'm going to snap to a point that I can keep my cursor on, because if I move the cursor, the surface is going to move. So I want to keep it here. Click once, and click twice, and hit escape. Maybe I was supposed to hit enter. Nope, it did it. So what it did is it created a copied surface of the existing ground. If you look over here in the Prospector tab, there's a points EG, and then there's a points EG parentheses 1. Okay, that's the one I'm going to use to merge in the corridor surface. To do that, I'm going to go ahead and right-click this points EG parentheses 1, go to Surface Properties, and I'm going to change the name. And for this one, I'm going to call, we'll call this Combined FG, which stands for Finished Grade. Okay. What's that telling me is that it's a combined surface of two different surfaces, and it's the finished grade at which the project should be once it's done. So we'll click OK, and you can see that it changed names. Now to get the surfaces to combine, I have to paste the corridor surface onto the combined surface. Okay. So again, there's multiple ways you can do this. You can select it, you can do it, but I'm going to go ahead and open it up in the Prospector, open up Definitions, and under Edits, I'm going to right-click, and at the very bottom of this box that pops up, well, not the very bottom, but close to it, there's a command that says Paste Surface. I'll select it, and in this dialog box that just pops up, I want to make sure I select the corridor surface, so the north waterway surface, and select OK. Okay, now there's even more lines on the screen, so it's getting a little confusing. So what I'm going to do is I'm going to turn off the other two surfaces. I'm going to turn off the points EG surface, and I'm going to turn off the north waterway surface, the corridor surface. So let's turn this off to no display. And again, if you've done the surfaces webinar, you should know how to do this. Turn off the corridor surface to no display. So what you see now on the screen is the only surface displayed is the combined FG. So this here in the middle is everything that the corridor created on the surface. Okay? But once we go outside of the corridor boundary, everything after that is based on the points EG surface. So this is what the finished grade should look like in the end. And I can zoom out, and you can kind of see the grass waterway cut down through this whole surface. Okay, that's it. As far as corridors and corridor surfaces that's it. But the next step from here would be to create cross sections and be able to show the existing ground, the points EG file, and then the finished ground on top of it, so you can see where was the original ground and where is the design ground. Okay, so you can put your cross section into your plans, but we'll talk about that in the next webinar. Okay. The one step that I skipped over that you should not skip over, I did it to save time, but since I'm going to talk about it anyhow, should have probably just done it in the first place. The one thing I didn't do is if I turn my corridor back on, so again, go down and turn on C-Road Core, the three of them that was there, if I can find it, here they are. And type in REA. Okay, there's my corridor, and I'm going to go ahead and turn off the combined FG so I can sort of explain what I'm doing here. And I'm going to turn on my corridor surface, the North Waterway surface. And we'll go to 1 and 5 design. Okay, if you zoom into some areas in here, you can see that the corridor surface kind of assumes some data points outside of the corridor boundary. This red line here is a corridor boundary. If I select that, let me try to select the corridor. Okay, so everywhere outside of these highlighted lines are basically some assumed data that they're trying to use. Okay, and that's not what we do in practice. Remember, if you've had a topographic survey in TDP class, you know that this is no good data out here because there's no data points. So just like in the surfaces webinar, you just have to clean this up a little bit. Okay, so the way I like to do is change the surface style to the 1 and 5 contours and triangles, and click OK. And I like to use the edit surface feature and go to delete line and just select the lines that I don't want to be included with the surface. Okay, so those ones I don't want that one. And just make sure that it follows the boundary of your corridor. And to do that, it's probably a little bit easier if you put the surface behind the corridor. So if I change the display order for the surface to send it back, I can see the corridor on top of the surface now, and I can see everywhere where the surface is outside of the corridor, and I can keep adjusting it from there. Okay, so again, go back to edit surface, delete edge, and select right in there where it's not supposed to be, so it better follows the corridor. If I zoom in here, I can get this one. One last little one right in there. Okay, that's an important step. You should always do that before you merge the combined surfaces. Okay. Okay, now that's basically it for corridors. Again, it's not too hard of a step. Just make sure you get the right things selected that are supposed to be selected. You always want to make sure that you're going back and forth between the profile view and between the corridor section editor to fine-tune your final design. Okay. So with that, I think that I have gone over about everything that I want to show. I'm probably forgetting something, I'm sure. I don't know. Justin, can you remember anything that I might be forgetting?
No.
Okay. Is there any little things you might add on to what we've talked about yesterday?
No, but you have one question right off the get-go here. Could you run cut and fill numbers with this added surface and corridor?
Yes, you can. And whether to use the combined surface or the corridor surface, I do not have a better answer which one's better. So I assume they should give you the same answer. We have not talked about how to find quantities yet as far as earth fills and cuts. We'll do that in the last webinar, not the last webinar, but the next webinar where we talk about cross sections. We'll do that. That's kind of one of the last things you do, but I can go ahead and talk about it if we have time, Justin, if that's okay with you.
We have about 10 minutes left.
Okay. But just real quickly, we'll go over this in the next webinar, but let me turn on the combined FG surface. We'll call it ODNR contours. Okay. And if I select the surface, I can go up here to the ribbon and do the volumes dashboard. And I have to add a new volume. And the important thing here is to make sure you get your the base surface and the comparison surface right. And I always forget which is which, if the original surface goes on top as a base surface or not. I don't always remember, so but it's pretty easy to tell when you get to the end. If you have something that says, hey, you need to fill 90%, then that's wrong. You should have done it the other way around. It should have been cut, because on a grass waterway we're always cutting. Okay, but let's go ahead and select this surface to let's do the points EG, and let's change this one to the combined FG. And I'm not going to change the cutter fill factors. Again, we'll talk about this one in the next webinar. If I hit OK, the main thing is, if we're cutting a lot, you should see on the net graph it should be red. Mostly red. The green means fill, the red means cut. And under these values here, you can see the cut is 1865 and the fill is 84. And as far as are they correct values, typically on a grass waterway, can be anywhere from like 1.2 to 1.4, 1.5 cubic yards per feet. So if you do some backwards calculation, I think this is in cubic feet. Nope, it's in cubic yards. So basically, if you just take the total length of your waterway, and I can do that right here. If I pull up my calculator, total yardage is 1865 divided by my length, which is 1265. Hit enter, and it's 1.47. Okay, so I know that that's somewhere in the realm of reality of what it's going to be. Whether it's entirely accurate, it'll be close. But again, waterways are paid on per foot, so the fact that we're off a few cubic yards is not a huge deal, except the contractors may yell at you. So don't know how else to say that. But there is a way to print this off. Up here on the top left, there's this little sheet with a star. If you select that, it'll go to an internet browser. It'll have this fancy sheet here you can print off, and it'll have your cuts and your fills and your net and your total area and things like that. So that's something you can print off and put in the design folder. So I hope that answered that question. Is there any more questions? If there's any more comments on things you thought I did wrong or things that you think are sort of an easier or simpler way to do it, let me know. I mean, this is certainly the time and the place to mention that. Nothing.
Okay, I don't have any other questions at the moment, but again, if you piece all the 4 webinars we've done, hopefully this collects you to the point of being able to put the waterway design on the set of plans. We'll follow up with probably a couple more webinars here in the coming months.
So I think that, again, the next one is going to be cross sections, and we'll talk about the volumes dashboard, although I pretty much showed the whole steps there to do it. But we'll talk about that, and if I have time, I'll get into plan prep or finishing plans, meaning getting everything on sheet of paper as you can plot out. That's sort of the hard step. I know a lot of you want standardized templates to print stuff on, so we may get into that a little bit. You may like what I have to say, you may not, but that's kind of what we hope to go from here. And then ideally, the last webinar we do for grass waterway should be the final step to where you can start printing stuff off and you can turn them into the engineers for final approval. So that's the hope. And then after that, the future webinars, maybe we'll do an EFT, maybe we'll do gradings, whatever we think the need is for you guys.
The one question that did come up, and I wanted to just reiterate, is even though we're using a parabolic waterway as the base of the these last couple webinars, this process of building a profile or proposed grade and then attaching a certain shaped assembly to it to build a corridor to get a 3D cut or fill volume would apply to a lot of other shapes. If this were a above ground feature like a levee, it would be the same basic process. Or if we were going more as a trapezoidal shaped ditch, or even a more complex shape like the two-stage ditch, or a shorter structure like a pond dam, the process could be done pretty much the exact same with just some few changes. You'd have to obviously rebuild the assembly with the sub-assemblies, maybe add a couple more components there. You may change some of your styles and how things look a little bit, but the process is the same. Okay, well, with that, we'll conclude. I just want to remind everybody we've got coming up in a couple weeks on the 18th, we'll do the second of the GIS webinars, basic webinar, and that'll all build towards December 1st, and we'll talk about NRCS's hydrology tools to look at the calculating runoff values and watersheds for our projects. If you're a GIS user, that's kind of a pretty slick tool that we'll have Janelle Weiss go through. And then, like Justin said, we'll follow up with some more of these CAD webinars. If you have any comments, any ideas, criticism, critiques, questions, feel free to email either of us afterwards or later. The video will be posted on that YouTube site within, well, I'll say by tomorrow morning if you want to go back and follow any of the steps. Okay, one last call for any questions. Well, enjoy your weekend. Happy Halloween, everybody, and we'll talk to you next time. Thanks for attending.
Thank you.